All right, so welcome back. So um, we're going the other way now, where we want to express each rectangular coordinate in polar coordinates. So remember that the relationships that we use here are these two to figure out what r and theta is. Now, personally, I just like to draw the picture, but you can be formulaic about it. You can use this directly, figure out your reference angle, and choose the quadrant and put it in based off of the point. But personally, I just have always gotten a habit on a lot of these of just drawing the picture. You're not going to be doing so many of them that it's a lot of, uh, you know, extra make work. So I like to just go ahead and plot the point in XY coordinates and then use that to kind of help guide me through the rest of the problem. Okay, help guide me through the rest of the problem. Okay, so my point is -1 square root of 3, so that would be -1 in the x direction, square root of 3 in the y direction. So that would land us at this point, right here. And then I go ahead and drop down my perpendicular and my radial lines back to the origin. So I know this is going to be angle theta. So when I find theta, I know it's going to be in the second quadrant. And what I know is that the sides of my right triangle are square root of 3 and -1. So I just need to figure out the radius. So I can go in here and say, well, based on the picture, r is the square root of x squared plus y squared. In this case, r would be 2. And then we know that the tangent of theta would be opposite over adjacent, negative square root of 3. And so remember, at that point, we want to find the reference angle. So what angle gives us a tangent of square root of 3? Well, that is one of the special ones that you were kind of asked to remember. I can tell you that maybe you might forget, you know, maybe you might forget. Uh, and if that's the case, hey, pop on your calculator, do convert yourself over to degree mode, and do, the inverse tangent of the square root of 3, right, if you're not sure. Right? If it just doesn't, you don't remember, we see it's 60 degrees, so it's pi over 3. Right? So that's what I would do if you don't remember it. You can always convert degrees and then convert back. You should, of course, know that 60 degrees and pi over 3 are the same. So pi over 3. And then we're going to put that in the second quadrant. And if you've already drawn the picture here, you can see, oh, pi over 3 is going to be my reference angle. So I'm that much short of pi. So my actual angle for theta is going to be 2 pi over 3. So then we use the r that we had along with our new angle. And now we've written our point in polar coordinates. Okay. So I like to do that. You could, of course, just use the formula, which would lead to that. But this way, if you look in terms of a graph, you honestly don't even have to think about uh, the uh, the formula, right? If you just plot the point, you don't even really have to think about the formula that way. Now, going the other way from polar to rectangle, it's just easier to use the formulas. Okay, and so then we have this other one here, 0, 4. We want to convert that over to polar coordinates. Okay, so point 0, 4 would just be up here. So from that, we realize that we're 4 units away from the origin, and we know that our angle is just pi over 2, right, 90 degrees. So therefore, my coordinates 0, 4 would be a radius of 4 and an angle a 5 or 2. Okay, and so now we made the conversion back from rectangular over to polar coordinates.